reality. So let's give a warm welcome to our speaker.
Hi everyone, my name is Sergey Kozyrev. I'm from Atlassian, working as an Android engineer, and I'm going to share some augmented reality things with you. But first, let's talk about what is augmented reality, right? So augmented reality is basically, well, the overlaying of the computer-generated content on top of the real world, like it belongs to the real world. I don't know if it does make any sense by sound, but it's basically much better to see one time instead of like listen dozens of times. So this green little fellow looks like it belongs to this world, but it actually doesn't. That's just a computer-rendered content on top of the video camera. And this only became possible because of the rapid development of the handheld devices during the recent years. Basically, worth mentioning that this form factor, as you can see now, like tablets and smartphones, is a form factor that the majority of people on this planet will experience augmented reality for the first time, because there are obviously some really expensive and fancy headsets like Microsoft HoloLens and probably some other, but they are mainly for enterprise, and they are, like, yeah, as I mentioned, quite expensive. So what technology is empowering these augmented reality and augmented reality experiences? Basically, the first thing is the state-of-the-art hardware pieces that are embedded currently in everyone's phone. So if you talk about hardware for augmented reality, that's an accelerometer for the velocity and acceleration. That's a gyroscope for the rotation, and the magnetometer. Is anyone aware what is magnetometer on the device? That's like a compass bearing. Gives you a sense where is the North Pole, like where is the North, based on the magnetic field of the Earth. And of course, the main sensor for augmented reality is camera, because most of the augmented reality techniques rely on computer vision, which, like, you cannot see anything without a camera, right? Okay, right. So all these hardware pieces all together, plus some applied math and complicated algorithms, forms altogether a thing called a SLAM, which is an abbreviation for the simultaneous localization and mapping. That's the same technology that is used by autonomous vehicles and robotics, but we use the same technology here in augmented reality. And well, in quick version, SLAM gives computers the ability to understand the environment, memorize it, and rely on it. So it's like, yeah, it does what it sounds: simultaneous localization of myself and mapping of the surrounding to my, like, local internal map. Google provides us for augmented reality ARCore as a framework and a library to build amazing AR experiences and augmented reality applications. And this ARCore has its own implementation of the SLAM. And it has three main key features or key capabilities. So first of them is motion tracking. So as your device moves in the environment, in this three-dimensional space, well, let's say your device is over here, you can memorize its position and orientations, and when you transfer your device somewhere, like you rotate it and bring it to some other place, that's a new pose, new position and orientation. You can basically draw a line between these 2 points in the three-dimensional space. That's the motion tracking. The second key capability is an environmental understanding. Environmental understanding is basically, well, in the ideal world, probably after a couple of decades of developing of such technologies, it would be like a 3D mesh scene generated based on what computer sees around us. Current state-of-the-art technology allows us to detect on the phone surfaces such as planes, like vertical and horizontal planes, and also point clouds. We will touch this a little bit later. But yeah, that's basically understanding of the environment, ability to recognize things and understand. And the third key capability is a light estimation. ARCore allows you to detect the lighting environmental changes, and so you can behave, well, you can make your 3D objects to behave somehow to react on the conditions changes, on the lighting conditions changes, just as this little line is scared because of the darkness, right? So now when we learned some basic key capabilities of the ARCore as a whole, let's look at the API. And the API of ARCore is extremely simple and easy to use for the developers. Well, at least at the high level. At the high level, when you want to, usually in AR applications, you want to place some 3D objects on top of the real world, as we already heard. This Android object basically represents your augmented reality experience. It can be bound to the anchor. And an anchor is an abstraction level of the ARCore. So basically, you can map your 3D objects to the anchor, and anchor is something like sticky and steady. So whenever you rotate your phone and return to the same place, your 3D object will be bound to the anchor, and anchor will be in the same spot. So it's like steady place on the scene. And what is cool, actually, is that anchor can be created based on a lot of different things. So first of them is a session, for example. If you bind an anchor to the session, it would be like your 3D object to the anchor. So it would be like the 3D object bound to some distance from the camera, and as you move camera, it always flows like in the same position regarding to the camera. Your pose, I've already covered this. So pose, you remember drawing a line from here to here. That's like different positions over space, and it can so you can create an anchor based on this pose. And there is an amazing concept of trackable. So trackable is just an interface in ARCore, and they just extended plane trackable to have like not only horizontal but also vertical planes now are trackable. And there is also another term called point cloud. Basically, that's an array of points, of unique points recognized on the scene. So, for example, on the slide you see here, some points would be like edge parts of the screen. Probably these eyes would be like points, like some distinctive, unique points on the scene that can be like recognized over and over again to place the sticky, steady anchor to it. All right. Now when you learn API, go ahead and build amazing apps. So you go to the ARCore developersandroid.com, you open a website, and hold on, what is this? It's Java, Unity, Unreal, iOS. There is also NDK, SDK, things like that. Like 8 different types how to build things. So what do we do with that? Basically, I'm going to cover your differences between Java and Unity SDK, because basically Unity and Unreal are kind of two things of the same kind. That's development or game development environment and game development engines. And iOS integration, well, that's a little bit on the side. So if you talk about Java SDK and Unity SDK for ARCore, yeah, I know that's not the ideal slide. But if you look into on the boxes, so green boxes represents like positive sides of the platform of one of the platform, and the red ones gives you a bad sides of the platform. So in simple words, if you're gonna start and just build some hello world application, Java ARCore SDK probably is the way to go, because it's simple to start. You can run it on CI, like whatever in Android Studio. However, you already got familiar with Android environment. But when it comes to, yeah, and on the Unity side, you have to learn a bit of C#, you have to learn a whole new editor, things like that. But when it comes to, like, imagine the augmented reality scene where you have an object and you have another object, and they want to interact somehow, maybe with some music or audio, and maybe they even have a physics engine and gravity. They can fall down from the table to the ground, right? That's absolutely undoable with ARCore Java SDK. So for some time before previous Google I/O, ARCore Unity SDK was the way to go in terms of building amazing AR interactive experience. Just to give you some like feeling about it, this is how it was looking to build ARCore augmented reality experience with Java SDK, with ARCore Java SDK. We see a lot of bit masks manipulations and like bytes shifting, everything. This just builds simple green Android object. You remember in the very beginning, that's a color setting. That's absolutely unmaintainable, right? And for on the Unity side, usually when you develop some Unity ARCore applications, augmented reality applications, well, it looks difficult, but it has amazing 3D editor. It has all this physics and things like that, and has a concept of prefabs, which I which is one of the things I like mostly. Prefab is something like the object, like 3D obj file, and the textures, and some custom components. And one of the custom components could be a script, and script can have a behavior of this object. So this is your interaction between one object and another. You can like program it in C#. So that's why it was the recommended way to go. But then, during the recent Google I/O, Google released SceneForm SDK, which is an extension on top of ARCore SDK. And SceneForm SDK basically a game changer here. So it gives us high-level scene graph API. You can grab anchors and create nodes and put the 3D objects into it and establish some relationship between them and interaction in your Java code just from Android Studio. SceneForm SDK enables all of this. Mostly, thankfully, because of the Android Studio plugin that you can install from the plugin repository. It allows you to import, view, and edit 3D assets. And it could be arbitrary 3D assets, but their main goal was to support Google Poly. That's a bit different story, like separate story, but Google Poly is an amazing resource that's like a repository for the 3D assets where you can download and just drag and drop to your Android Studio, and it will generate you all the bindings automatically if you pre-install the Android Studio plugin, SceneForm Android Studio plugin. Well, basically, just to give you an understanding how it looks now to render a 3D object on the scene with SceneForm SDK, this is how it looks. It's just a one-liner. You create a view renderable from some link to asset folder. That's it. Basically, that's not the link to asset folder. If you read carefully enough, you can spot here R layout test view, right? Isn't it amazing? We can create a 3D renderable objects that would be represented like in the three-dimensional space on top of your real world using your layouts that you're already familiar with. You probably built a layout, right? Anyone built a layout? Yeah. All right. That's the default thing how we build UI on Android. When it comes to sharing your augmented reality experience with friends, because basically sharing experience is something fun, right? Google announced it on last Google I/O 2 features. First of them is augmented images, and the second is Cloud Anchors. So this video on the slide represents augmented images concept. Augmented image is an extension of trackable interface. You remember trackable interface? So that's just another way to create an anchor and place augmented reality experience on top of this anchor. And this augmented images thing has its own capabilities and limitations. One of the limitations is that image database for augmented images is something that holds images that can be recognized on a scene. So you put it in real time or in runtime, you can put something from gallery there. So that's kind of sort of a limitation, 1,000 images, but I think it's enough. What is really amazing is that it can handle up to 20 images simultaneously and place augmented reality experience on top of it. This basically enables you, everyone is a fan of Harry Potter's universe, right? You remember the newspaper where on top of every image they had an augmented reality experience. So I tell you, they build it with ARCore, with augmented images. Yeah, or you can build it for yourself or for like any arbitrary other program. Well, there are some restrictions to images to be used. They are on the slide. What is also interesting is that Google provides you a separate standalone command line tool. It can assess your image and give you a number from 0 to 100, where 100 means this image is awesome, I'm going to recognize it for you, and 0 means no chances you're going to recognize this image. So you should use images something like 70 and above. Next video represents the concept of Cloud Anchors. Basically, when you scan a surface, you recognize the plane, you put the AR experience on top of it. ARCore allows you to grab all the visual characteristics and upload it to the ARCore Cloud. And then from any other particular phone, and you'll be able to do this from your phones if you have Android device. By downloading an app I will provide on the last slide and try to view the same AR experience by just checking the surface where I placed the AR AR assets. Okay, before I jump into the demo, Cloud Anchors has some also limitations and capabilities. One of the great capability, like great feature of Cloud Anchors in ARCore is that Cloud Anchor can be created based on any anchor. So there is no restrictions. You remember session, posts, trackables, like Cloud Anchor can be created on top of any of this. Cloud Anchors are supported out of the box for Android, Unity, and iOS. So you can create multiplayer, cross-platform, augmented reality experiences using both form factors. And yeah, another limitation is that Cloud Anchors expire after 24 hours. Why is that? Because if you detect the surface and grab a visual characteristics from it, probably there is very, very little chances that they will remain stable during more than 24 hours, because this thing's gonna move and like table is gonna be like relocated to some other rooms and things like that. So the surface will change, and that's why it expires after 24 hours. Let's see a short demo, and I will show you first the app, and then I will show you key points how to build app like this. So this is an app based on one of the Google samples for ARCore SceneForm, but it has incorporated example of usage of Cloud Anchors. You'll be able to see to find it on my GitHub. So basically, this is a DevFest demo. Okay, everybody can see like the screen. All right, it has like 3 activities and 3 buttons: Solar, Host AR, and Resolve AR. We're only interested in Host AR and Resolve AR. So you can go with Host AR button. This brings you a camera feed. Say hi. Okay, this brings you a camera feed. You see these little white dots, it means it recognizes the surface. You can move a phone here. If I go here and click it, it sets the augmented reality experience on top of the surface. And it binds it to the anchor where I basically placed it. And by the way, you see the sun and rotating planets. Now I'm clicking on the sun, and I can, here we go, Anchor hosted, you saw? So, did you mention the number? No? Okay, doesn't matter. Well, it does, but I have like preset this in, and you have another number. So you can use the seek bar, and this is just a regular Android XML layout XML seek bar. You see the rotation, like they start rotating faster, and if you stop them and increase rotation speed, each of them is rotating faster than it could. And you can also like it. By the way, after this presentation, it would be awesome if you can like some of these experiences. And we'll see how many likes we can get. Likes is also synchronized with Google Firebase. All right, now if you hit resolve, I need to grab an ID number to resolve it. So to resolve, you would need to use 672. So I'm hitting 672 here. And as you can see, I hit OK. It loads me pretty much the same screen. And as soon as it will recognize the place, it's mapped to the same place, you see? The interesting thing is, if I go to any other place and put 672. 672 it was? Yeah. Okay. So because the floor is basically the same here and here, it is pretty much the same. But the thing is, there are some distinctive features over here, like this column and like table, corner, and things like that. So if I try to recognize it over here, it will not be able to recognize it, because it actually can track the surface, right? But it's not recognizing it here. But only if I move to this place, it should eventually pop up here. So you will be able to download the app, host it whenever you want and play with it, or just hit resolve, go with 672, and check this floor before the table, all right? See how many likes we can get in a day.
I got 60.
You already did 60, nice. All right, just a 1-minute demo about how it had been built. So in the Android Studio, this is a solar activity. This is an activity that gives you all the like 3D drawings, SceneForm stuff. You saw this rotational stuff. In clip version, this is a model renderable. This is a type that hosts your 3D objects, and you load them from the assets folder. They gives you completable features that you would need to wait from. One of the interesting parts here is that this snippet on top of the sun was created from the completable feature from view renderable instead of model renderable, which is created based on just layout. You remember I've told you this is just simple linear layout with your sig bars, with your button and text views, right? Actually, I'm going to jump to host activity and resolve activity. They both extend solar activity. The difference is that when you click on the surface for host activity, when view anchor is created, I just call AR scene view, which is also just a view that you embed in your main activity, in your solar activity. Get session, host cloud anchor. Here you go, you got your cloud anchor. The difference here, the problem here is that it looks like a blocking call, but it's not a blocking call actually. It gives you a dead cloud anchor, and then you should check it in some like timer task, or for every scene update, for every scene frame update, you should wait for cloud anchor state. You see here from cloud anchor, I'm getting the cloud anchor state. Check if it's successful, then now it's live cloud anchor. Now you can share the cloud anchor ID from it. So there is no async API at the moment because they still develop the technology. And in the resolve activity, actually you can see here that I'm operating with storage manager. That's just based on Firebase. We don't need to go into the details here. But in the resolve activity, I just grab a session from AR scene view, resolve cloud anchor, and basically doing the same thing. I'm waiting for the cloud anchor state to become successful. And if it's successful, I call the set new anchor, and this actually creates you a solar system and places on top of this anchor. So yeah, guys, this is a link to the demo APK. This is the QR code to the same link if you want. Please use code 672 or place this AR experience to whatever surface you want. And some useful links like Code Labs from Google. They have 3 Code Labs for ARCore, and the course on Coursera, and the GitHub account, Twitter, and email if you have any questions. Thank you very much.
Don't think we have time for like centralized questions.
That's what I was trying to.
Running a little bit behind schedule, but I'm sure you'll have to answer any, like after the session, if you have questions, just rock up. We've got morning tea now. We're cutting that a bit short to catch up, and then we'll continue in both rooms. So check out this session.
Please catch me whenever you want, and I'll answer all questions that I will be able to about AR.